MysteryWire.com, home of the unusual and unknown. From Area 51 to the paranormal, it's your source to the most vetted UFO stories and special investigations in the world. Take a journey into the universe of MysteryWire.com.
Eric, I'd like to, reading the book, The Zoologist's Guide to the Galaxy, it just struck me that you were having fun with this, that it was a fun project to do. Am I right?
Absolutely. Of course it's fun. I mean, what we do is always fun. This is one of the great things about being in science. It's something that just took off. It was something that arose so naturally from the kind of work that I do anyway, on animal communication. But once you get into it, it's one of those fields where once you get into it, there's just so much you can say and so much you can do, and it flows really nicely.
Does this grow out of, say, you're watching movies, sci-fi TV shows, you see aliens that look just like us coming to Earth, and it kind of bothers you as a scientist? You want to say, hey, that's not what aliens should look like.
That's kind of been a thought retrospectively, but no, you rarely think about it. I mean, sometimes you do. There are some things about TV aliens and movie aliens that you just look at them and you think, well, that's not right. That's not going to happen. But mostly we pretty much put up with it because, the role of aliens in entertainment is entertainment. The example I always give, you think of Mr. Spock in Star Trek, right? This logical, it's not that he's an alien. He's there to express this idea of what's it like to be logical all the time, what's it like to have no emotions. So we don't really look at TV aliens and think of them as being real in any way. Sometimes, of course, you get movies like Arrival where they make a big effort to try and represent something that's going to be realistic. And then we do seem to, scientists sometimes sit down and think, well, that doesn't quite work out, does it? But it doesn't really bother me.
Arrival, I was going to ask you about that because it's so thoughtful in exploring the kind of ideas that you get into in the book, in the nature of communication and how difficult it would be.
I think it does, and I think it's a field that's really coming into its own now. It used to be a very fringe field, right? Listening for signals from outer space was something that people did in their spare time. There's a lot of money in it now. There's a lot of research money going into listening for signals of alien intelligence, and the Breakthrough Listen project is very well funded, and they're doing a lot of really interesting work. So I think there's been a shift. I think people have started to take these questions much more seriously and try to address them a little bit more thoughtfully, and that feeds through into entertainment. People want to think that we're addressing these questions in a more rigorous way.
For scientists, it's like, as over the last 20 years, it seems like the ground rules have changed. I mean, the discovery of so many thousands of exoplanets now, it's not just guesswork like the Drake equation. We know that they're out there, and the discovery of water in our own solar system on other bodies, it increases the possibility of life out there. So give me a sense of the general change in views within the scientific community about how likely it is that alien life exists, how likely it is that intelligent life might exist at some point.
I think you're absolutely right. The scientific community has undergone a revolution in recent years. It's just that where we previously had to guess how many alien worlds there may be, we're now coming to the understanding that there are many more than we ever expected. But more than that, because being driven by this observation that there are so many alien planets, we've developed a whole new host of technologies which are increasingly giving us the hope of being able to investigate those planets. And the example I give is this recent discovery of an indication of phosphine gas on Venus. We don't really know what's causing that. We don't really know what the origin is. But the fact that we were able to detect it, the fact that we were able to go out and look, and the fact that we did go out and look, that scientists are actually probing the atmospheres of other planets, just gives you a feel of how much the game has changed, how much we are actively looking now, whereas before there was really no sense in which we were actively looking for extraterrestrial life.
Let's use Mars as an example, talk about that a little bit, because tomorrow NASA is going to land a rover on Mars, and it's going to look specifically for signs of life. What would you expect? What kind of evidence could be realistically be found? Microscopic fossils of some sort? And if that is the case, how might it change things here on Earth? How might it change things for you in your line of work?
Well, I think that the interesting thing about Mars is that it's clearly very inhospitable at the moment, but we believe that the Martian environment used to be much more conducive to life, and that if we can look back, if these missions and rovers can actually find evidence that there once was life on Mars, it helps us to answer probably the biggest question in astrobiology, which is how rare is it for life to arise? There may be billions of planets in the galaxy, but if life is almost impossible, they may all be empty. So having a handle on how unlikely that one event was, the origin of life, gives us a really, really good idea to how populated the galaxy might be. So I think that's really the benefit of the Mars mission, is to be able to look back in time and look at how Mars used to be, and see whether it's possible that life arose there, either independently from Earth or possibly the two are related.
Let's say a year from now, NASA announces we've got pretty good evidence that life did exist on Mars. Microbial, we've got remnants of it from long ago, but just that announcement, what impact does that have on Earth? How does that change us?
I think that, like a lot of these scientific discoveries, they tend not to affect the general public too much. I think that people would like to see aliens come and visit us. And short of that, we live in a very big universe. Any alien life is likely to be so far away that we are very unlikely ever to meet it. And that's kind of disappointing for most people, I think. So I think that the discovery that life once existed on Mars probably won't change society very much. It will completely revolutionize the way that scientific research is done on astrobiology. It will drive a tremendous amount of inquiry into the kinds of conditions where life could have evolved, kind of conditions where life is possible, and it will undoubtedly accelerate our investigation of other planets. So I think it's an exponential effect. I think if there were to be a big discovery on Mars, what would then happen is that we would redouble our efforts to find life on further planets, more distant planets, and eventually I believe we would.
Where do you stand on the discussion in media right now, and I guess in some scientific circles, the idea that we could be Martians, that life existed on Mars and came here on meteorites or chunks of rock that were blasted into space? Is it a possibility?
So if we discover that there was once life on Mars, that's the big question. That's really the big question. And it comes back to what I said about how rare life is how rare it is for life to arise. Because if we share a common origin with this proposed Martian life, that's quite likely. I mean, I don't think anyone seriously dismisses that as a possibility. Meteorites will pass from one planet to another. We have good reason to believe that life could survive such a journey. If we're not related to life on Mars, if we could show that life existed on Mars and it didn't either originate on Earth or we didn't originate on Mars, that would revolutionize everything, because the chances of life arising independently on two planets in the same solar system would imply that life is extremely common, extremely common. So I think it really would be one way or another, it's a watershed. It would change everything.
Same sort of question regarding Europa. There's a really cool mission coming up to Europa in a year or two from NASA. They're convinced that there's an underground or under 60 miles of ice. There is an ocean there. And even some NASA folks have speculated there could be more advanced, not just microbial life, but the equivalent of fish on Mars, on Europa. Does that fit with the general themes that you explore here about how life springs up and how it evolves?
I think these underground oceans are incredibly interesting possibility, both in terms of looking for extraterrestrial life and also in terms of thinking what it might be like. I think there could be, yes, I think there certainly could be complex life in an underground ocean. The challenges are much greater. We have, of course, plenty of energy from the sun on the surface of the Earth. You don't get that in an underground ocean. So it's a little bit of a question where the energy that drives life would come from. But of course, there is still plenty of energy around. There's the radioactive core of the moon, and there's the gravitational friction. So you could speculate that life could exist there. And then one of the themes that I investigate in my book is how that life might be different from life on Earth, on the surface of a planet. And there are many things that would be very different. Obviously, the way that you sense the environment would be different. Light would probably not be an important medium, as it has been on Earth. And there's also the question of directionality. You know, all life on Earth is the way it is because it evolved on a rock, essentially. You know, we have legs because our ancestors had to crawl across the floor of the ocean. Now, if that's not the case, if you have life that's floating, that's evolved and is always free floating in a liquid, then it might be a completely different form, a completely different design.
Well, you discussed some really exotic and imaginative type life forms that might be out there in your book. Can you share a couple of those with us that really kind of leap off the page, some of the more exotic ideas?
Well, specifically for underground oceans, the big question really is: are you going to be symmetrical? One of the largest innovations, one of the most important innovations of animal life on Earth was having a left side and a right side. You can't overemphasize how important that was. Because if you want to move on a surface, you've got to have a left and a right. You've got to have a front and a back. So the 99% of all the species on Earth have this, of all the species of animals have this left-right symmetry. And it goes really well with the legs. Legs work really well in pairs. So I think it's reasonable to assume that animal life on other planets, on the surface of other planets, would also show these properties. They'd be symmetrical, they would have legs and things like that. Now, that huge advantage, of course, disappears if you don't live on the ground. If you've evolved in a liquid, suspended in a liquid, then all of a sudden there's no advantage to having a left side and a right side, and there's no particular advantage to having legs either. So the physical structure of an organism that evolved there would be very different. But it's interesting that even on Earth, even in the ocean, even life forms that float in the ocean on Earth still reflect, to a large extent, almost all of them still reflect that origin at the surface between the water and the ground, of having a left-right symmetry.
You know, I do a lot of work in UFO world, ideas that people share with me about aliens visiting us and what their interests might be. And, you know, there's such an intense interest. You see it in the media, in other worlds, other intelligences, searching for exoplanets and SETI and those kinds of efforts. And it always occurs to me, I'm an animal guy. I mean, I love animals, and I do a lot of stories about animal welfare issues, how interested people are in life elsewhere, and at the same time ignore so much of what's happening to life here. I mean, we're in the middle of a mass extinction effort where so many species are just disappearing, and people think, why do we have to worry about one bug disappearing or one fish? And you look around, you look at nature videos and oceanic videos of the really strange, exotic, totally alien looking life forms that exist here that we don't pay much attention to, or a lot of us don't. And at the same time, we really want to pay attention there. I wish that the same kind of passion in the search for exobiology would apply to the life forms that we already have here. Do you feel the same way?
I think that's an excellent summary. I mean, to a large extent, the book that I've written is about life on Earth. Life on Earth is the only life we really know about. And the book's about extrapolating what we know, what we can understand about how life on Earth works, and using that to make conclusions about life on other planets. But at the same time, It's a book about life on Earth. It's a book about the diversity of life on Earth and why it is the way it is and how we understand our place on our planet. Because if we do discover life on other worlds, it will, to some extent, diminish our place in the universe. We're no longer unique. But my point is that if we do discover life on other planets, that life will have evolved through the same processes that we evolved. And so rather than diminishing our place in the universe, it actually gives us a sort of fraternity with all life across the galaxy. So we share in common with these hypothetical aliens that we may not have discovered yet, a certain evolutionary process. And of course, all the more we share that same evolutionary process with life on Earth. So if we can feel an identity with alien life forms when we discover them, then we should most definitely be feeling an identity with the other life forms on Earth.
Yeah, I think about people who focus on life elsewhere. They're thinking about one dominant species, intelligent like us, on some other planet, and that's where their thoughts are, not thinking about the array of life that might exist on some other world. I mean, I can't imagine that there's anything like Earth. That's just incredible. There are so many species and forms of life we haven't even cataloged yet here. Could you imagine another world like Earth somewhere with this range of life possibilities?
Well, one of the arguments that used to be very popular against the existence of intelligent alien life was that the conditions that Earth has experienced have been very specific and very favorable to the evolution of complex life. So certain things about having a moon, for instance, having plate tectonics, the way the continents move around on the surface of the Earth, a whole range of very specific things that drove diversity of life on Earth. Without that, life on Earth would remain fairly mundane, some bacteria perhaps, and a few other things. So there is a sense in which there were certain things about Earth that made life quite as complex and as diverse as it is as it is today. But that's now that we understand more about the range of exoplanets, and that there are so many exoplanets with so many different conditions, and with moons, and probably with plate tectonics and atmospheres and so on. It seems likely that diverse ecosystems will also exist on other planets. Now, one thing about Earth is that although life has existed for 3.5 billion years here, it was only really about 250 million years ago that the complexity really started to accelerate. And once the ecosystem on Earth became complex, once there was a really diverse range of creatures, and particularly once there were things like flowering plants and insects to pollinate them, and a lot of the diversity that we see today, then it just accelerated. It accelerated and accelerated and accelerated. So if we were to observe intelligent alien life, it would be a pretty good bet that they come from a planet with a very complex, very diverse ecosystem that allowed that intelligence to evolve. We didn't evolve for 3.5 billion years partly because life on Earth was simply too simple for too much of that time. So
you allow yourself to speculate what happens to us. Say, what will humans look like a million years from now? We think about the planet now, we're the dominant life form, or the top of the food chain or whatever, but what we might become. I'm thinking about Ray Kurzweil and his prediction for the singularity, where we were able to upload our consciousness to computers and then maybe someday to the cloud. AI, you do discuss in your book the possibility of mechanical or bot type life in the universe. A combination of AI and artificial bodies. Can you talk about that a little bit? What might be out there, what we might become in, say, a million years?
Yeah, if we survive, of course.
Yeah.
If we survive the next couple hundred years. Well, there's an interesting question. Many SETI researchers believe that, many prominent SETI researchers believe that alien life, when we discover it, is most likely to be artificial. Simply because, humans have only been around for 1 million years or whatever, and we've only really had technology for a couple tens of of thousands of years, and look what we've already achieved. What will we be like in another? What will our technology be like in another million years? So there's a strong argument that intelligent artificial life should be very widespread. The problem, of course, with that argument is that if we wonder why we don't see any signs of alien life in the universe, and we look in the night sky, we don't see a lot of aliens around, then we should be doubly wondering why we don't see any alien artificial life. If artificial life is so much more efficient and so much more successful, if our technological abilities are really growing that fast, why isn't there a civilization out there, a million years old, that has intelligent robots that are swarming all over the universe? We just don't see that. So one possible explanation is that, we all die out. It's we kill ourselves. We're victims of our technology, and that's unfortunate. And I think that's what we're seeing happening in our society at the moment with climate change. But there are other possibilities, one of which, for instance, is that we do upload ourselves to the cloud, and aliens have all uploaded themselves to the cloud, and that's why they're not exploring. But these are, of course, pretty speculative ideas. We don't know the answer.
Yeah, I mean, in a million, how far we've come in the last 50 years, the progress has been astounding. In a million years, do we need bodies? Do we still live on Earth? If we're in a cloud sort of consciousness, would we even be able to recognize an intelligence that's a million years more advanced than us? I'm thinking about Avi Loeb, the Harvard guy who's talking about that asteroid that came from an interstellar place somewhere, and he's getting a lot of grief for suggesting that it was created and it's artificial as opposed to just a piece of rock.
Yeah, I mean, I think that we don't have any difficulty understanding the intelligent or limited intelligent abilities of simple life forms. So I certainly don't see that an advanced civilization would have difficulty in understanding us. We can look at snails and amoeba and look at how they move around and how they sense their environment, and we understand them pretty well. So I don't think that there's any problem suggesting that an alien life form would not pay us any attention. I think they probably would. Whether or not we would recognize a highly advanced intelligence it's an interesting question, but the laws of science don't really get overthrown. There's a sort of popular idea that as we discover more and more, we abandon what has been discovered in the past, but that's not really true. The laws of science are only refined relatively slowly. In a million years' time, we will understand physics a lot better, but it won't be a very different physics. It will still be the balls will still fall when you drop them. So I don't think that these hyper-intelligent aliens will be quite as different as some people make out.
You make the point in your book that the laws of physics we figure are pretty constant everywhere. The rules of biology are a little more flexible, though, which is sort of the fun of what you explore in your book, all the different kinds of exotic possibilities that might be out there. That is what you're saying, right? It's a little bit squishier when it comes to biology.
Well, I think most people probably hadn't even thought that there are laws of biology at all. The laws of physics are very simple, and we understand them and we experience them all the time. But when thinking about aliens, most people would say, well, they could be anything. Anything is possible. We can't assume from our observations on Earth that we know anything about what aliens would be like, because there are no laws of biology. But that's not true. There most certainly are laws of biology. And those laws of biology have a very direct effect on what aliens must be like. In the last 100 years, we've come to understand a very great deal about how life evolves. And the key point of my book, of course, is that life evolves. Life cannot just spring into existence fully formed and all ready to build a spaceship. So as life becomes more and more complex, it only does this through a set of really quite simple rules and laws that govern what kind of complexity is going to occur. And as we understand that quite well, how that operates on Earth, we can apply them cautiously, like you said, a little bit more squishy, but we can apply them to other planets as well.
Well, I appreciate in your book and in reading your resume that your understanding and your the fun you have with speculating about life elsewhere is based on what you have done, boots on the ground study here. You're not just in your office writing about this stuff. You are out in the field chasing wolves and learning their communication, studying dolphins and how they communicate. So that sensibility that you bring to this is really greatly appreciated. Your appreciation for what we already have.
Yeah, and well, you know what? Observation of what's around us is where it all begins, isn't it? It's not, you don't actually have to devote your life to science to be able to observe what's around us and observe the way that animals are behaving and extrapolate from that. And I think that's one of the great things about zoology. Everyone loves animals, and you know, no one gets tired of watching them.
I tell you what, one last comment. I was thinking about Europa. Say there's fish down there in that ocean under all the ice. I worry that the first thought is not, hey, how do we communicate with these fish? It's, I wonder what they taste like. You know that's coming.
Yeah. Well, I think that's a long way off. I think that's a very, very long way off fishing on Europa, fortunately.
All right, The Zoologist's Guide to the Galaxy. It's a terrific book. I will be speaking to you again in a couple of weeks, and we'll get into more detail about it. Thanks very much.
That's fantastic. Thank you so much.